Hello friends, welcome back to our next session of e-learning. My name is Vijay Sonar from R.C. Patel Pharmacy College, Shirpur. Today I am going to talk about interpretation of IR spectra. In the previous lectures we have discussed all the zones of IR spectra. We have seen the different ranges for different functional group. In this lecture we will try to illustrate the structure of the compound based on the IR spectrum. So what I will try to do here is I will show you some of the spectra and I will give you some of the examples, and based on that you have to identify that which compound corresponds to this spectra. So just look at this spectra, and now these are 5 different possible compounds, and now we have to identify that which compound corresponds to this spectra. Now when you have this type of problems, you are given with a single spectra and you are given with the 4 or 5 different options. So what you can do is do not directly try to read the spectra, but you just go in the opposite direction, and what you have to do is just try to eliminate the compounds which are not possible compounds. So now we'll try to understand. Look at this molecule and try to find out what is the unique feature of this molecule. This molecule have a double bond, that is it's alkene. Okay, so now this is alkene type of molecule. So try to find out the carbon-carbon double bond. It falls in the region of 1600 to 1680 centimeter inverse. Okay, go back to the spectra and now try to find out whether is there any peak in this region. Of course no, there is no peak in the region 1600 to 1680, so this will not be the possible answer. Now let us move on to the next spectra, next molecule. So as we have seen, there is no carbon-carbon double bond peak present. So also the second molecule where we have the carbon-carbon double bond is not possible, so the second will not be the answer. Now look at the third compound. It has OH group. Now where the OH group stands 3200 to 3650, we have a strong and broad peak for OH group, and here we have an broad peak of OH. So this could be a possible answer in this case. So now this could be the answer, so we will put this compound on hold. So similarly, as look at this fifth compound where we don't have an OH group, so it means this is not the answer. Okay, so now what we have is compound third and compound 4. This one we have these 2 possible answers, and this compound have this carbonyl group as a key function. So where the carbonyl group stands is in between 1650 to 1780 centimeter inverse, and if you look at the spectra, there is no peak of carbonyl group, so this is not the answer. So this is your answer here. So this way you can determine the structure, or you can determine the possible molecule for given IR spectra. So what we have done here is we have tried to eliminate each molecule, each option, and ultimately we have reached to the final answer. We have tried to find out what is the key feature in each molecule and what is the possible signals in the spectra, and then by this way we have tried to eliminate the wrong option. So this is the right answer, 1-propanol, and this is the spectra of this compound. Now we will try to see the few examples, the next examples. So suppose this is the spectra. Now the next compound, and you have these 5 possible answers for this spectra. Now for this molecule, what is the key feature? We have an OH group and then a carbonyl group. So as we have seen, there is no broad OH peak of OH group, so we can eliminate this compound. So this will not be answer. Similarly here also the alcohol is there, so this is not possible because there is no peak of OH. Now for this compound we have this carbon carbon triple bond. So look at the functional group table, 21002 2260, so weak, medium, peak, and just try to find out whether we have in this region, as there is no peak, so this is also not the answer. Now we have these two compounds remaining, the last, the fourth one and the fifth one, and the common feature in both these both the compound is a carbonyl group. Now just try to find out in between 1650 to 1780, and we have this one peak, and there is now nothing special difference between these two compounds. Both the compounds have carbonyl group, and we have confirmed the presence of carbonyl group here. Now how can we differentiate in this case? So for this you need more practice. We need to understand the small differences when you have similar structures. Now if you look at both the compound, the upper compound is a ketone and the lower compound is an aldehyde. Okay, and if you refer the different textbooks of IR and IR ranges, you will observe one key note, and you can make a note of it, which makes an aldehyde category of compound different from the other compounds containing carbonyl groups. Like I meant to say, you can easily differentiate the aldehydes from ketone, ester, acid, etc. Now if you look at this here, in the ketone you have this carbonyl group attached to methyl, and in case of aldehyde you have directly a CS stretching, or so it means you can observe a CS stretching band, two CS stretching band in this region, okay, near about in between 2600 to 2800, and this is a peculiar characteristics features for aldehyde. If you observe these two peaks in between 2600 to 2800, which is a stretching of CH, and this is the peculiar feature of aldehyde, so this confirms that this spectra is of an aldehyde. So the answer here is of course the aldehyde and not the ketone. So this way you can follow the strategy that when you are provided with a spectra and you are provided with some molecules, so what you can do is just follow the elimination rule, so that what we can do is the compound which is not possible, we just try to rule out. So this is the best way to identify the compound and to compare the spectra. Thank you very much for watching this video. If you have any question about this topic or IR spectra, you can put me in comment box. Thank you very much for watching this video.